Hello, Connor, and whoever else is watching this. I am also, by the way, going to put all 3 of these videos up on Google Classroom for you guys. If you're, by chance, maybe studying over the weekend and you want to see something, I'll just put them all up there, okay? So, starting with chapter 4, we've got like 11 problems left, and then we're going to do 2 proofs together at the end, which you don't need to write down, but we're just going to walk through them and then we'll see what the proofs are like, okay? So, last question on the bottom of this page, chapter 4. Here we go. Find the measure of each side. Measure of each side. If they give me the vertices, the coordinate points, how do I find the measures of the sides?
I don't know. You measure
the distance. We're going to do the distances of each one. Okay, so if my vertices are E, F, and G, what is one of the sides? EF would be a side, okay? EF would be a side, FG would be a side, and EG would be a side, yeah? So we're going to find all of those distances, okay? But before we do that, it says classify the triangle by its side. So let's talk about what the classifications might be. After we figure out what the sides are, we're going to see what it is. How can we name a triangle by its sides?
So we have to use the
so equilateral. Yep, we're going to use the distance formula. Equilateral means 3 same. So all 3 sides the same. If it's all 3 sides the same, it's going to be equilateral. If 2 of the sides are the same, it's going to be isosceles. Did I spell it right? ISOSCELES. Yep, that means 2 same. And if none of them are the same, it's scalene. Okay? Now, we're looking at the sides and we're determining which of those 3 is true. Now, we will, after Christmas break when we come back, we're still talking about triangles. We will talk about the angles. Don't write this down. But we'll talk about the angles. And how do you name a triangle by its angles?
Acute, obtuse, and right.
Acute, obtuse, and right. Okay, now typically you look at the angles to figure out which one it is, right? You can actually, and we're going to learn how to do this, you can actually use the side lengths to determine whether it's acute, obtuse, or right? In fact, we know how to do it for a right triangle. It just has to fit a squared plus b squared equals c squared. And if that's true, then it's a right triangle, right? Okay? So we're going to figure out after Christmas break when we come back how to judge an acute and obtuse triangle by its angles, by looking at the side lengths, okay?
Right there for a second.
So you don't need to write this down. But just for the sides, classify the triangle by its sides. That's all we want. After Christmas break, we'll do the angles as well, okay? But sides, equilateral, isosceles, scalene, okay? That's what you need to look for. All right, over here, let's do the distances. I'm going to get that off the screen so it's not. Is that bothering you?
What?
That little thing?
Where?
This little guy, that box. That
iPad,
gray box.
100% if you're or your MacBook.
There we go. Okay. It bothers me because it's there. Okay. All right, so the distances. We're doing the distance formula, okay? It's like this. This squared, this squared. Yeah, it's a squared plus b squared. Perfect. Okay, we're going to do all of those distances.
Actually,
Distance. Right. Oh. And distance. Okay, and I do the inside, like the parenthesis part stuff in my head. Okay, like I think you guys do that as well. So like looking at E and F, how far apart is -3 and 1?
4.
4. How far apart is 3 and -1?
4.
4. Okay, 4 squared is 16. 4 squared is 16. So this side is the square root of 32. Perfect. Okay, now we're going F to G. All right, F is going from 1 to -3. That is
4.
4. From -1 to -5, that is
4.
4. And 4 squared is 16, and 4 squared is 16. So this is the square root of. All right, so at this point, I have a square root of 32 and square root of 32. Which option is it not? It's not scalene, right? 2 of them are at least matching. Let's see if the third one does, okay? So now we're going E to G. We got -3 to -3. 0 and 3 to -5 is 8. Yeah, 3 to -5 is 8. 0 squared is 0, 8 squared is 64. That is the square root of 64, or just 8, right? Like that one is just 8. So I've got a side that's 8, a side that's the square root of 32, and a side that's the square root of 32. What kind of triangle is this? Isosceles. ISOSCELES. Okay, there we go. Isosceles. Good? Happy happy with that? Any questions about that? Lots of stuff. Okay? Alright, moving on, down below, 35. Okay? Alright, when they give you diagrams like this, do not disregard the markings. These are like superly important to find things. Superly important to find, okay? They want us to find the measure of angle 3, so we have to find like the measure of 1 and 2 before we can find 3, right? That's how this works. Okay, so let's do this. Alright, this is 110 degrees.
110 minus 180 is
So this
70.
angle is 70 degrees. Do you buy that?
Yes.
This is 70. Okay, now, the markings that are in this triangle have that. That means this is an isosceles triangle. So what do I know?
So that means the other, that one needs to be 70.
The angle 1 is 70 degrees as well. Does that make sense? If it's isosceles, then this angle and this angle are the same. Does that make sense that that would be the case?
Yes.
If the two sides are the same, the angles have to be the same, right? Yeah? So this is 70 as well.
70 plus
Okay.
70 is 140, so the other one.
These two add up to be 140, which means that this angle right here is
40.
40. Which means
40
that
plus
this
90
angle right here is 40. Okay?
130, so
So
130.
What is angle 2, by the way? They don't ask for that, but what is angle 2?
Like 15.
140.
140, right? Because they have to add up to be a straight line, right? Okay, so we have 40 is this guy down here. How did I know that this was 40, by the way?
Because
Vertical angle.
70
They're vertical
Yeah.
angles, okay? So this is 40 and this is 90.
Yeah.
So
I'm not even gonna, no, hold on, I'm not even gonna add those
90
together.
minus 40.
These two have to add up to be the other 90, right?
Yeah.
Okay, so angle 3 has to be
50.
50 degrees, yeah? Okay, so we kind of like mapped that all the way through. But the key there is to pay attention to the way it's marked. That's an isosceles triangle, which means the two angles have to be the same, and the two sides have to be the same, okay? So that was the key there. Good? All right, moving on. Identify the congruent triangles and name their corresponding congruent angles, okay? So they're asking for which angles match up. And then when it says identify the congruent triangles, they're asking for a congruence statement. A congruent statement. All right, do you remember what a congruent statement was? You had one of those on your test.
This triangle of ABC.
Triangle, whatever is congruent to triangle, whatever, and you just have to put them in order, right? Okay?
Yeah.
All right, so what do you want to name one of the triangles?
ABC.
ABC, sure.
C, D, E.
ABC. Okay, so A goes with which one? What's A go with? F. Okay, so we've got to go F. B goes with which one?
D.
D, so we've got to go D. And then C has to go with G. Is that true?
Yeah.
So that's my congruent statement. So we have identified the congruent triangles. Okay, now we're going to name the corresponding congruent angles. So if I do the angles, if I name the angles, I'll move him over. I can just look at the way that I have it ordered here. I know that angle A has to be the same as angle F, right? I don't even have to look at the diagram anymore. I know that angle B has to be the same as angle D, and I know that angle C has to be the same as angle G. Okay, now what happens instead if I would say the sides? Name the corresponding congruent sides.
No, don't.
What's one of the sides called?
AB.
AB. Okay, AB is a side. AB is the first two letters here. That would have to be the same as FD, right? Okay, what's another side?
BC.
BC. If I look at the order here, BC is the last two letters, so that has to be DG, yeah? Okay, and then my third side would be AC. AC has to be the same as
Can I what?
FG. Do you see how that works? You did not have to do the sides, but if I ask you for that, that's how you name the sides, right? This side equals this side. This side equals this side. Got it?
Yeah, hold on.
All right, I'm holding on.
So F, it's what FDG.
Oh.
Because I have them backwards.
Why do you lie? That's fine.
Dude, you guys gonna knock down like at least 3 threes. Okay, you go.
I'm gonna puke that.
Okay. How about that? Good? Moving on?
Wait. Yep.
I'll leave it
Yeah.
kind of
No, you're good. No, you're good.
I just wanted to make sure I had that all right.
All right, 37. Determine which postulate, if any, can be used to prove that these two triangles are congruent. When they ask for that, they're saying like which one of these. So there are 8 of them. Side, side, side. Let's list all of them. Side, side, side. We have side, angle, side. We have side, angle, angle. And we have side, side, angle, right? Then we have some of the other ones. Angle, angle, side. We have angle, side, side. We have angle, side, angle. And we have angle, angle, angle. Okay, let's talk about which ones don't work.
The ASS and SSA.
The naughty one doesn't work, and then the SSA doesn't work. Okay? Literally, I told somebody this the other day. Literally, this one, SSA is literally ass backwards. Have you ever heard somebody say that?
Yup.
This is literally ASS backwards, right? That one doesn't work. Those two don't work because they're the same. What else doesn't work?
AAA.
AAA doesn't work. Okay. The other 5 do work, but technically, SAA is the same thing as AAS. So I'm just going to count it once, right? So we have these 4 that do work. All right.
Wait.
Now,
Up here, didn't you say since these two are the same, then that means that that one's the same?
In this triangle right
Uh-huh.
here.
oh, sorry.
Sorry.
If these two sides are the same, then that means these 2 angles are the same.
So that doesn't have anything to do.
Okay, so this one. Determine which of these postulates, so we can use one of those 4. Determine which postulate, if any, can be used to prove that these 2 triangles are congruent. So this top one is congruent to the bottom one. We're trying to see if that's true. What? Okay, you're on the right track. We know by the reflexive property that this side that they share has to be the same, but be careful and look at the way that it is marked.
You said A
Be
or
careful
SAS
and
or
look
AAS.
at the way that it is marked.
Yeah.
This side is not equal to this one. This side is equal to this one. Okay? And then this one is equal to this one is equal to this one, right? Okay, so here's what I'm going to do. I'm going to draw that, but I'm going to make it a little bit more exaggerated. Let's do this. Let's say that I have this going on, right, where this is the same as that. Okay? Then I'm going to draw this one like this, where this one's the same as that. That's exactly the way it's marked, right? This is a little bit more exaggerated, but are those 2 triangles congruent?
Oh, so there's no
No.
way.
So no, it says if any. It would have been side, side, side if this had 2 markings and this had 1 marking. Does that make sense?
Can you zoom out?
But
Which
here-
ones did you say were the same? The SAS and A or
Okay, but do you see why
AAS?
that's not side, side, side? Because these 2 are in the same triangle. The 2 sides that are matching are in the same triangle, so that's not going to work. The 2 that are the same are SAA and AAS.
SAA and
Wait, so it'll be S.
Okay, so what do we put here? None. Determine which postulate, if any. None.
There ain't any.
Not congruent. They are not congruent. Okay? Alright, otherwise it would be one of those 4 that you would use, yeah? Okay, but this one, the way that it's marked is kind of tricky, so be careful. Don't let that trick you. Okay? Alright, now we're ready for some probability stuff. Here we go. Probability. 38. A spinner has 4 equal sectors, numbered 1 through 4. So I have 1, 2, 3, 4. The spinner is spun twice. Make an organized list of the sample space. What's a sample space? What's a sample space? What? What you could get. A list of the things that you could get. So I'm spinning it twice. What could I get? I could get what?
1, 1.
I could get a 1, 1. What else could I get?
1, 2.
I 1, 2. I could get 1, 3, or I could get 1, 4. Okay, what else could I get?
A 12, a 13, 14.
I could get a 2 and a 1. I could get a 2 and a 2. I could get a 2 and a 3 or a 2 and a 4. Do you see what I'm doing here?
Yeah.
This is my list, okay?
of the what?
Or I could get a 3 and a 1,
Samples.
a 3 and a 2, a 3 and a 3, or a 3 and a 4. This
Oh,
is an
list of what
organized
you could
list
get.
of all of the options or the sample space, okay? Or a 4 and a 1, a 4 and a 2, a 4 and a 3, or a 4 and a 4. Now, how many numbers or how many combinations are there in my list?
16.
How do you know if you got them all?
Because 4 times
Spin number 1. How many options could I have gotten on spin number 1?
4.
4. How many options could I have gotten on spin number 2?
4.
4. And 4 times 4 is 16 total combos, right? I would check that to make sure that you aren't missing any of them, right? Okay? So like if it's flipping a coin, if I'm flipping a coin twice, 2 times, how many things are in the sample space?
2.
If I'm flipping a coin 2 times,
4.
4, right? 2 times 2 is 4. What happens if I'm flipping a coin 3 times?
Wait, how many times is it? 6, no, 8.
3 times would be 2 times 2 times 2, right? Heads, tails, heads, tails, heads, tails, which is 8, right? You see how that works, okay? So that's how you know if you're missing any from your sample space, okay? So 16 different combos, and we have all 16 listed. All right, here we go. 39. Carl is creating greeting cards from a website. He has to choose from 2 types of paper. He has 5 different fonts. He has to choose one of each of these categories. He has 5 different greetings inside, which would be like what it says on the inside. And then 3 different envelopes. He is choosing one from each of those categories.
So we'll go 2 times.
How many
5
different
times
combinations are there?
150.
2 times 5 times 5 times 3. That is the fundamental counting principle. So there's 150 different things that could happen, or 150 different cards
When did we do this chapter?
that could be made. This is chapter
Beginning.
12. This is at the very beginning. This is right after chapter
Oh.
0 is what we did.
Oh.
Okay, number 40. What is the probability that a randomly selected permutation of the letters shown below will spell the word permutation? So what I'm doing is I'm taking these letters, ripping them apart and putting them in a hat, and I want to pull them out and I want them to spell the word permutation
Except
exactly.
we have to get rid of the duplicate.
Okay, so the deal here is there are 11 letters, which would normally be 11 factorial, right? Except for this. This is a permutation with repetition. Because which letter repeats?
T.
The T. So if I would take these 2 T's and flip them around, it would still spell the same word, right? The same letter, right? I think we did that with the Reese's, the Reese,
Yep.
R-E-E-C-E. So you guys have a letter that repeats 3 times. So if I would switch any of those E's around, it would still spell the word Reese, right? Okay, so we're going to divide by what?
Oh yeah, I remember doing this now.
What do we divide by?
2.
2
Literally,
factorial, technically, which is still just 2. So we divide by 2 factorial. The formula is n factorial over r1 factorial times r2 factorial times r3 factorial. As many of them as I need. Here I only have 1 letter repeating, but if I had more than that, I would multiply them all together. Now make sure that if you're going to type it in all at one shot, you put the bottom in parentheses, okay? All right, so what is 11 factorial divided by 2 factorial? Do you guys all know where your factorial button is on your calculator?
Yeah,
Okay,
I think I remember.
locate it. Make sure you know where it's at. This is a really huge number, like 19 million or something.
Yep, 19,958,400.
Yep, 400. Okay, but read the question again.
Probability, 1 over.
What is the probability of me spelling permutation exactly? High chances?
Yeah.
No, holy cow. Really low chances of happening.
I take
Not gonna
it.
happen.
I take it.
Lots of combinations, which makes it a very low chance of me
Well,
actually
I bet
actually
my whole life on that.
getting the word permutation exactly.
So what's the lottery then?
Got it? I don't know. The lottery is
We
like.
did it
Wait,
in,
so if I only have
in
one,
our
do I have to
biology
use-
class.
And one in like
Mhm.
5
Maybe
If I
like
have
1 and 2
one
thousand.
bottom thing, do I
Yeah,
have to?
you don't have to do parentheses.
Where's mine at?
Okay, where's yours at? Yours is on the main. Oh no, yours is under PRB.
19.
That's where probability is. So you go down to factorial.
Yeah, I had to teach Casey what
Okay.
that was.
All right, so there's that. Good. Let's go on down and do some more. So, 41. I always chuckle at this question. And I have a math brain. I'm looking for numbers in a paragraph, right? Like that's what I look for because that's going to be the important part of the paragraph.
3
But then they do this 3 of 10 thing and they spell the words out. Like they spell out the word 3, right? So that always trips me up because I'm like, where is all my information? 3 and 10. So if you need to see it in letter format or number format, there it is, right? 3 out of 10 members of the AV Club are randomly chosen to read the morning announcements for the month of May. What is the probability that the 3 freshmen are chosen? Okay? All right, first of all, we need to figure out how many combinations there are when I'm choosing 3 out of 10. So what is this going to involve? I'm choosing 3 out of 10 members.
Those special ones.
Yeah, this is either going to be an NPR or an NCR. I'm choosing 3 out of 10, okay? Now, NPR, if I'm doing NPR, this is where order
That matters.
John didn't get the reference.
Order matters, okay? In NCR, order doesn't matter, okay? Which one do I want?
Order matters.
You want order matters for this
No.
one? 3
No,
of the
order
10 members.
Doesn't matter.
I'm just looking for the 3 freshmen. Does it matter what 3 freshmen, like the 3 freshmen in
No.
order? No. So I'm looking for no order, okay? Now on the test, I can't promise you that it'll be a C. It might be a P, but you need to make sure you know the difference. So this will be 10C3. Okay, find it in your calculator, type it in, 10C3. 10C3. What is 10C3? 120. Okay, read the problem again. What is the probability that the 3 freshmen are chosen? What's the probability that the 3 freshmen are chosen?
3 out of 20?
Where's the C at?
Now we're talking about groupings. Okay, there is only one grouping out of the 120 that includes all 3 of the freshmen. Okay, we're not talking about individual members. We're talking about groups of 3, right? There is only one group of 3 out of the 120 that includes all 3 freshmen. Otherwise, we might have a group that has 2 freshmen and a junior, or 2 freshmen and a sophomore. Only one of them includes all 3 freshmen. Does that make sense? Okay, so that's the probability. All right, 42 should be easy. We're finding the probability that K, excuse me, K lies on XP. XP is from here to here, okay? The probability K lies on XP. How do I do that?
7 over 28.
7 over, now why 28?
Because addition.
The whole section is 28 units long, right?
Okay.
7 out of 28 is 1/4, okay? I don't care if you put 1/4 or you put 0.25 or you put 25%, they all technically mean the same thing. Agreed? Okay, I will take any of those answers.
Where's K at?
K is just a point. Point K is chosen randomly. So it's like, I want point K to live somewhere here. Good question. Okay, good?
Yep.
All right, in a circular spinner, we're going to draw a picture. In a circular spinner,
Yeah.
the sector colored yellow, it has an angle of 85 degrees. How big is an 85-degree angle?
Tiny little bit less than
A tiny little bit less than 90 degrees. So I'm going to do like this, and I'm going to go like there, right? This is an 85-degree angle. So we're almost a quarter of the circle. Keep that in mind. Almost a quarter of the circle is 85 degrees. They want to know what is the probability that it will land in the yellow. 85 out of 360, because we're dealing with degrees. 85 out of 360, if you divide that, is 0.23 something. I don't know. 0.236 or 23.6%. Now, is that close to a fourth? Yes. You know what I get a lot of times as an answer? 85%, because they're like 85 out of 100, right? But 85 is not a percentage. 85 is the degrees, and you have to go out of 360, okay? So keep that in mind. Got it?
What if we went with a fraction?
What? That's fine. If you want to do it as a reduced fraction, that is fine. Yes.
Probably do that.
Okay? All right, 44 and 45. Here we go.
Okay.
This one says, here's some key words that you need to look for. Here we are drawing 2 cards, okay? So we need to decide when you multiply versus when you add probabilities together, okay? So let's talk about multiply versus add. When do you multiply probabilities together?
No idea.
multiple categories.
You can't use.
When you have multiple, okay, so kind of along the same lines. You multiply when you're doing 2 or more events, okay? You add them when you're only doing 1 event, okay? So here's how this works, right? I'm drawing 2 cards versus drawing 1 card. Now I'm adding when I'm drawing 1 card because it might say, I want to know the probability of getting 1 card and it being either a king or a 7, right? I would add those 2 together, but I'm still only drawing 1 card, right? That's how that works, okay? Other things you can look for is keywords. What keyword will you see with multiply? What keyword is it with multiply? I want this thing
Or.
and this thing because I'm drawing 2 cards. So here is an and. I'm going to do it in caps. A and D. Since you're drawing 2 cards, I want this card and this card. That's 2 cards, right? An adding event would be or. Like I want this 1 card to be either a king or a 7, right? Okay? So that's how that works, all right? So those are the things you're looking for. 2 cards are drawn from a standard deck without replacing, underline that because that's another important thing. What is the probability that the first card is an ace and the second card is a king? We're going to be multiplying, okay? So first card being an ace, second card being a king, and we are not replacing. No.
So
No replace, okay?
1
So
out of 52 and
No, hold on. How many aces are there?
Oh, 4.
4 out of 52, okay?
And then
All right, now I'm not replacing, so how many cards are there now?
51.
51 cards, how many of them are kings?
4.
Yes, still 4 kings, right? Okay, now when you're multiplying, please reduce beforehand because it'll make your life easier. 4 and 52 becomes 1 and 13, okay? Anything else reduce? I don't think so. 4 and 51 won't reduce if 4 and 52 did. So how do I multiply this together now? Multiply across, tops and bottoms. So 4 times 1
4.
and 13 times 51 is like 663.
Yeah.
Is that high chances of that happening?
No.
No,
Totally.
not really. It's better chances than the permutation question, right? Like it has a better chance than that happening. But 4 out of 663 is still like less than, I don't know, that's like way less than 1%. Okay? Not way less than 1%. Less than 1%.
Equals
Okay? 45. What is the probability of drawing an ace? There's that word. Or a spade from a standard deck of cards. Now, how many cards are we drawing? 1. An ace or a spade. That means 1 card, okay? But I have 2 categories. I have ace versus spade. A spade is like this thing. Ooh, that looks terrible. Let me fix it.
Oh my goodness.
Spade. That still looks terrible. Whatever. Ace, spade, okay? Ace, spade. We're adding those together. All right? How many aces are there?
13. Wait,
4. 4 aces. Ace is like the number 1. 4 out of 52. How many spades are there?
13.
13 out of 52. Okay, now there's something tricky that happens. Okay? There's something tricky that happens with this. Kind of like the not replace thing that we had in 44. You have to be careful when you're replacing, not replacing. What do you have to be careful of when you have this one going on?
Can be both.
Can they be both?
Yeah.
Can you have an ace and a spade at the same time?
I guess.
See, that one was better. I don't know. There's 4 aces. There's 13 spades. Can you have an ace of spades? There's 1 card that's an ace of spades. So what do you do with that information?
You subtract the 1.
You have to subtract the 1 that's counted in both categories, right? Okay, 4 out of 52 plus 13 out of 52 minus 1 out of 52. Your bottom number will stay 52, but the tops you just like do that. So 4 plus 13 minus 1?
16.
16 out of 52, I can divide both of those by 4. 4 out of 13. Okay, so just like replace and not replace, you have to be careful of the can it be in both categories when you're adding, right? You have to subtract those, okay? All right, now,
out of 52.
I don't have any room for proofs.
you don't need to write these down. You don't need to write these down.
I do need to write these down.
No, you don't need to write them down. They're too easy. Okay, good? All right, grab your green sheets if you've got them handy. You can use the screen sheet on your test. We're going to go through 2 proofs. You don't need to write these down. Just watch me as I do them and locate where this stuff is kind of at on your green sheet, okay? So the very first proof that you will have is something that's an algebra proof, okay? An algebra proof is just like solving something. These are very, very, very easy. Very easy proofs, okay? So we're starting with this. This is what we're given, and this is what we're trying to prove it comes out to be. So I know what the answer is. I just have to show you and justify the steps going through.
You have to solve for it.
Yeah, you're just solving algebraically like solving for x, okay? So what do we start with? Start with the given. 3x plus 4 over 6 equals 5. That's the given, okay? Good? You don't have to write this down. There's that, okay? All right, now what would you do?
Multiply by 6.
You would multiply the 6 over? Sure. Okay, so times 6 times 6. So the very next step would look like
Property of multiplication.
3x plus 4 equals 30. And that is the multiplication property of equality. Okay, go ahead and find the multiplication property of equality and those property of equality things on your green sheet. It should be like toward the very, very, very top
Oh, wow.
of like one of the first things that we wrote down, right? Those are the properties of equality, okay? So make sure you have those written down. Otherwise, it's not, I mean, you can like memorize that. You don't really have to look that up on your green sheet, okay? Multiplication property of equality. All right, now next, your next step, what would you do?
Probably add 4 in.
Subtract the 4. So 3x is going to be equal to 26. What did we just do there? That was the subtraction property of equality.
Use a po.
Okay, property of equality is saying it's remaining equal if I do it to both sides, right? We subtracted 4 from both sides, so the property of equality, it stayed equal, okay? Now, last step, divide by 3, divide by 3. So x equals 26 over 3. Now, Gabe this morning said that is 8 and 2/3. Oh, that's the bell. 8 and 2/3, but you're gonna leave it as this right here, okay? Good? That was the division property of equality. All right, we'll go over the next proof right before you take your test on Monday, okay? Can we remember that?
Yeah.
All right, so you help me remember.